So to begin learning all the various topics of algebra, you first need to, well, grasp a foundational understanding of it, and really all the basic topics that you're going to be using throughout the course, and many other courses in your life, like calculus and trigonometry. Um, Even if you go into math career, you're going to need these basic topics. So let's start by asking ourselves, well, what is algebra? And algebra is the use of symbols and shapes and letters, really anything to describe missing values. So you could have like x, y, z. You could use a square. You could even use like a circle. Um, Greek letters, even like theta. You get the point. You could use any of these letters and symbols and shapes to describe the value that you're looking for. And that's really what algebra is defined as. That is the heart of algebra. So there are many ways you can go about finding these missing values, and that's what the subtopics of algebra are all about. As we move on throughout the course, you'll learn things such as solving equations, solving systems of equations, you have quadratic equations, you have expressions, all these sort of things that are dedicated to finding the hidden value. So when you have these shapes or symbols or letter or whatever you're dealing with, there's some concepts that you need to grasp when using them. And the first I would say is, well, expressions. So expressions are these letters and symbols and shapes being used to express a certain value. So for example, if we said, well, y plus 10, so 10 more than the hidden value, that would be an expression that expresses your hidden value plus another 10. If we had, for example, 3y plus 4, I'm using y too much. Let me say like x. 3x plus 4, that would mean, well, 3 times your hidden value plus another 4. If we had something like x, or let me say z divided by 3, that would mean, hey, z, z divided by 3, your hidden value divided by 3. And you can really start to come up with the craziest things for your expressions. So you could say, okay, x, 3x plus z over 3 minus 10y plus 453. And why not throw in some thetas and squares in there too? Plus 50 theta. I don't know. But this is also an expression. So, really, that's what expressions are. And that leads us into our next topic, which is equations. And equations is when a certain expression is equal to another expression. So expressions can, I forgot to mention, can also be like numbers, like 4 or 3, these kind of expressions, even 365 million, blah, blah, blah. We'll say 365, yeah, 365 million. These are all expressions as well. So when you set like one expression equal to another expression, so for example, let's take our original expression here, 3x plus 4, and we'll set it equal to how about 8. Now this is an equation because 3x plus 4 is its own separate expression and 8 is its own separate expression. So that's essentially what equations are. When you see that equal sign in between the two expressions, that's how you know it's an equation. So let me write in here equation. Another foundational concept in algebra is, well, combining like terms. Now, Really, you do this all the time when you're adding and subtracting numbers. Say you had something like 3 plus 4. This is essentially combining like terms. These are two individual numbers that you are adding to get a sum, so equals 7. What you essentially just did was combined like terms. Now, if you look at it in a different way, you could say, well, what's 3x plus 4x? Now, you might be intimidated by the adding in of the x variable, but really it's the same concept. 3 and 4 are things that are called coefficients. And what coefficients do are they multiply the variable at hand by a specific number. So in this case, the 3 is in front of the x, so that means that we're dealing with 3 x's, right? And the 4 is in front of the x, so in this case we're dealing with 4 x's. So let me write it here. 3x is the same exact thing as x plus x plus x, and it's the same thing as, well, 3 times x, except the multiplication sign isn't there. So that's a really convenient thing in algebra, is that you don't have to write multiplication signs between variables and their coefficients. You can just write it right in front of them, and that's why you won't see those multiplication signs when you're dealing with coefficients. And if you have a coefficient, actually, let me say this real quick. This variable, if we were to say something like 3 times 3, basically it's the same exact thing. 3 times 3 is the same thing as 3 plus 3 plus 3, aka, well, 9, right? So if you have the coefficient of a term, right, and the coefficient of that variable, or rather the variable that the coefficient is applied to, is the same as another term right here. So like you see that 3x and 4x, the variables are the same. It's the same x, right? And you have coefficients in front of them, and the expression is asking you to add them together. Well, what you could just do is add the coefficients together. So you could say, okay, 3x plus 4x, that's equal to 7x, because 3 plus 4 is 7. Now you have 7x's. If you look back to here, you see 3x is the same thing as x plus x plus x. Therefore, 4x would be the same thing as x plus x plus x plus x. So when you add all those x's together, you'll get 7x. They also function with multiplication and division. So 3x times 4x, in this case, you wouldn't just multiply the coefficients together, you would also multiply the x's together, and you get something that's called an exponent, which is a topic that we're going to go on in a much later video, but 12x squared is what you would get. But yeah, coefficients, when you're dealing with them and they're of the same term, you oftentimes they will be combined together. And with multiplication, actually, it works even if the variable is different, but I digress. So that is combining like terms, basically. So because both of these numbers have an x in them, they can be combined using their coefficients, and that's what combining like terms is. If I could come up with another example, like y plus we'll say x plus 4z, and we'll add this to like 2y plus 10z plus 3x. Now we can't do something like adding y and x, because y and x are different terms. We can't add 4z and 2y because z and y are different terms. But we can add y and 2y because they both have the y, and we can add the x and the 3x because they both have an x. I'm gonna actually color code these, so we'll make x red, we'll make z yellow, and we'll keep y green. So if we were to do this and add y and 2y, we could combine their coefficients. And when you see just a variable alone, there's always going to be that invisible coefficient of 1, right? So 1 plus 2, 3. Y plus 2y is 3y. And then we can combine the x's, and we get x plus 3x, which is 4x. And then we could do the same thing for the z's, so 4z plus 10z, and that is going to be plus 14z. So that's basically combining like terms. Let me actually make that yellow. And then I think the final foundational concept of algebra that we're going to go over here is going to be graphing. So let me get a coordinate plane in here. This works. And with a coordinate plane when you're graphing, you're going to have an x coordinate and you're going to have a y coordinate. So let's make something that's called a table. And a table of values will describe to you an x coordinate and its corresponding y coordinate. And when you combine these, they will form a point that you can plot on your graph. So you have your x's and you have your y's. So let's make some points here. We can say 0, and then for y we can say 1. Let's say for x 1, y 2. We could just keep going in this pattern, why not? 2, 3, on and on and on. The line keeps going. So let's plot these. You would look on the x-axis for the x coordinate, so 0, and then you would look at the y-axis for the y coordinate, so 1. So then this point would be right at 0, 1, so right here. And you do the same thing for the other points, so 1, 2, and you could do 2, 3. So essentially, you only need 2 points to actually graph a line. If you know that what you're graphing is a line, then you only need 2 points to graph that line. So let's pull out our ruler here and connect these points into a straight line. And that is what we get. And in later videos, we're going to be getting more into graphing, whether it's for linear equations like slope-intercept form, point-slope form, standard form, or quadratic equations, and we're going to be graphing parabolas, or systems of equations where we might have to graph equations to find a solution. All of that might sound very confusing, but as we progress into the course and watch more of these videos, then you will see what I mean. So yeah, these are basically the foundational concepts of algebra that you're going to be using throughout not only this course but other ones like Algebra 2 and calculus and trigonometry, as I said earlier. So I hope you found this helpful, and in our first video we are going to be working on how to solve equations. So I hope you found this helpful. Thank you for watching, and I'll see you in the next one.